Hello everyone, I'm here to present this work where we assess the mechanization level of a few construction activities where we conduct that based on the performance of the crew and try to quantify the mechanization index of these activities. We also introduce to the craft workforce the use of electronic performance monitoring, targeted mechanization of the tasks to catch their perceptions about that. First, some introduction regarding the method applied. The on-site construction tasks are drivers by the workforce, the equipment, the machines, the tools and products. And all that is most of the time handled by the craft workforce. In this, we established that 9 processes for modeling the construction tasks. It's not so detailed as example the Terblick, the motion study that grasping, moving or releasing. Neither is too wide of this used approach, classical approaches to measure industrial process as operating, inspection, transportation, and delay. However, that 9 processes can interconnect with this classical approach. Next, I will fast present that 9 process. First is that free-hand performance, when the worker is performing a task with one or both hands, handling materials or products. Many times they are assessing their own work by auxiliary tools. As example, use a measuring tape. It's often observed that use of manual tools, example, a trowel. And nowadays you can observe more and more the use of electric and electronic tools on site. This constitute, in our concept, a mechanical process. As well, it is a mechanical process when workers are operating some machines and equipments. Not common yet are that automated process, and of course it is a mechanical process. And as human beings, the workers will have some time of idleness, and it is natural. As natural is that the worker will be walking, traveling across the construction sites, and many times they will be carrying some products or some machines to the place they will effectively do the job, perform the tasks. Well, it is based in this worker 4.0 motion productivity process that the quantitative mechanization index is performed. It is based on the proportion of that, as I indicated before, that mechanical process over only that the process point as operative. It means we are avoiding here the portion of non-production work or supportive work. As I will bring again that figure, and you can see here we just use for the mechanization index that green part, that operative one. Also, it is important to notice that again the process should be modeled based on the crew performance, not only in 1 or 2 workers. And after that, over the results, we suggested that classifications being low, moderate, high, or very high. And of course, in these pandemic times, it's quite impossible to go on site and conduct experiments. And we confronted that situation, and we tried to move forward because we had, of course, a small sample, and you conduct some Monte Carlo's method to try to model that process and try to face that challenge we had. And we think it will be, we can see that in detail, and we can use this again in some experiments. We experienced that 4 different sites. The first one was that a mensory activity in a residential building, and it achieved a low mechanization index. Only the brickwork was analyzed without the coating. And this activity it's very manual, where the workers are handling the blocks and using manual tools to pour the mortage. The crew was there composed with 3 masons and 1 assistant. And there is a demand, of course, for supportive work, such as to supply the mortar, supply the blocks, or cut the blocks also in smaller pieces and transport it to the front zone. And approximately 64% of the time, workers are carrying out operative and productive activities. And most of the transport, as I told you, was regarding that the supply of mortar and bricks in the front zone. The workers carry out, of course, inspection of their own worker to guarantee the plumb and the level of the elements. And as you can see in the right corner of that sensibility analysis, that tornado graphic, we can see in the highlight that that high impact in the model, in the output of the model, just that machine operation does not affect that output. Similar here was activity of masonry in the commercial building, and also it's achieved a low mechanization level, 2% of difference, and the crew also was composed of 3 masons and 1 assistant. Different here, forklift supplies the mortar and the blocks on the scaffolding elevation where the work was carried out. Drill and a grinder were that electronic tools we see the workforce using, and different manual tools are used as a throw, a float, a shove. As well, some auxiliary tools are used to measure and position the panels. The piping activity reached a high level of mechanization, 42%. That piping was summarizing the activity consisting mechanization, disruption of the existing pavement, mechanical excavation, and placing the pipes and the braces, and after to make the compactation of the soil. In average, 5 to 7 workers were observed at one point of view. Low inspection rate was observed as there are few measures are needed for this specific work execution. Since transport was mostly carried out by machines and their operators, workers that working around mostly transporting just the tools and the accessories. The delay was a massive delay, and that is related that the crew was, the most part of the crew was all the time waiting the operation of the machines, the action of the machines. That increased a lot that delay time that do not operate in virus. Sorry. Finally, the ethics activity reached less than 2%, being considered low. A crew composed of 2 officers and 1 assistant performed the technical insulation of the external walls. The activities corresponding to cutting and fitting the mineral insulation boards, apply mortar to the entire surface and press on plate and floating, inserting the plaster reinforced mesh and testing the finishing plaster. There is a demand for support services such as to supply the mortar and some pieces of the boards. It can be seen that the lowest process performed was the electric and electronic tools that was used to mix the mortar, and it was possible to measure that most of the time the craft workers are handling a hand tool to cut the boards or I use some float to perform the action of laying the mortar. As a result, it can be seen the similarity of masonry tasks, both residential and commercial ones, as well the dissimilarity with ethics and culminating in a big difference for the piping task. It was a very different process, the piping from the others, and we can see that the difference in the mechanization level. That quantitative mechanization level measured is found to well represent the process, as you can see the difference on site, and we can see the difference in the value of the numbers. It is observed that each text achieve a consistent mechanization level based on their particularities, as I told you. Significantly, it was measured that although the piping task was a high achieve a high mechanization level, its operative and productive time was lowest in the other ones. And from this, we can highlight that increasing the tasks level mechanization might not be enough to obtain a better productivity or to boost productivity. That you should compose that with the process, and we can have, as I told you before, that confront with people with weighting the work of the machine, and that will and because that the importance of the modeling the crew performance. This this distortion was mainly related with that interrelationship of the activity in the lack of synchronizing between the workers and workers, the workers and machines, and that can be assessed. Regarding the craftwork first reactions, as I told you, we dress up some craftwork workers on site and talk about electronic performance monitoring, and we talk about the mechanization of the work, and we talk about that possible benefits and threats of this type of technology. And that was very clear, the lack of awareness about that. Some workers say that monitoring health could be a benefit, and also we try to understand if some comfort or discomfort wear this type of wristwatch. And some workers say they have no problem with it, and another one say it could be a little discomfort to wear this during the day. And that was also very clear, the discomfort regarding filming directions. They all times dislike that action of filming, and that is important to the next experimentation on site. And I'd like to quote that because that to me was very impressive. A worker said to me that mechanization is bad because it takes away our work. If there are more machines, we have less work, and that is bad. And we should target to make this clear, that the concept and the idea and the purpose to make the tasks more, to bring more tools or more machines to on-site, to make the work less effort, and that will bring more health, more safety, and more, of course, more productivity, and that will be good for both, for the employer and the employees, and you should target that awareness on site. Concluding, from the experiment, it becomes clear that the use of more equipment might not lead to boost productivity. And you should to model the process based on the crew, to quantify the mechanization level based on the crew, and try to understand the relationship between the workers and the machines, and that will be the way to increase performance. Of course, we should measure it and have this quantitative way to measure the levels of mechanization of the activities, but should be important to observe and analyze all the process, all the crew. Most of the craftworks say have no awareness about innovation, and should to deliver that information, bring education to on-site based to talk about innovation. And of course, more data is needed, because this is just the starting point. We need to go to on-site and collect more data with different tasks to achieve a benchmark and improve our models. And finally, I would like to thank my colleagues, Pedro Mêda, Professor Miguel Gonçalves, Professor Hipólito Sousa, and a special thanks for the craft workforce and the managers and the companies that allow us to perform that on-site experiments. And thank you for the audience. Bye.